Before we get started, I just wanted to plug that the slides are available on GitHub, so you can take a screenshot of the QR code. It'll drop you in this GitHub repo, and you can follow along, save for later, whatever you want to do. But yeah, I'll just pause here for a second so folks, if they want, can take a picture. Okay, going once, going twice. Cool. So before we kick things off, just a brief intro about who Doris and I are. So hi, folks. I'm Savannah. For those of you who I have not met, I'm super excited to be here. I've been working on Python for about 10 years or so, and this is my third in-person PyCon. I am also a Python core developer, where I maintain our JIT compiler that was introduced in Python 3.13, as well as the argparse module that many of you probably know and love. My work on the JIT is part of the broader Faster C Python initiative, so I get to collaborate with wonderful folks across Microsoft, Meta, ARM, all those great places. I also serve on the Jupyter Foundation governing board on behalf of Snowflake, working to build healthy collaboration between Jupyter and its community and members of the Jupyter Foundation. Previously worked on the Pylance language server, so if you're familiar with Visual Studio Code, you probably use Pylance. I also worked on projects foundational to the container and cloud native ecosystem, like the Docker runtime and the CLI, and worked on the Azure Developer CLI, which helps app devs deploy their applications to Azure. But I currently work at Snowflake, focusing largely on our notebooks experience, as well as Python developer experience across the company.
Hi, everyone. I'm Doris. As a brief background to myself, I've been in the Python data space largely within the last decade or so. My Python journey actually started when I was doing my undergrad in astrophysics, and I was working with large amounts of cosmological data for astronomy research. And this is when I learned about Python, Pandas, all the great stuff like Jupyter and stuff. And it became really clear to me that all of these amazing PyData tools can help accelerate scientific research. And so I was so inspired by this that for my PhD, I actually went into building tools for scientists, domain scientists, and so on. And a lot of this work was focused around how do we take human-centered approach to designing data science tools, work with domain scientists to build these low-code, no-code visualization tools. I designed a system called an open source library called Lux, which is essentially an automatic visualization tool within Jupyter Notebooks. And I also worked on Modin, Scalable Pandas. I'll talk a little bit more about that project later today. After my PhD at Berkeley, a couple of my lab mates and I started a company called Ponder, which is built on Modin open source. And it really focused around this mission of how do you help data teams and developers become more productive with the tools that they already know and love in the Python ecosystem. Namely Pandas, and help developers work on data at all scales. And in 2023, Ponder was acquired by Snowflake, and I'm now working at Snowflake to continue some of this work, both in the open source and also trying to bring our best-in-class Python experience to Snowflake. Cool.
All right, so let's take a look at what we're going to cover today. So first, we're going to talk a little bit about Snowflake and the PyData ecosystem. Then we're going to walk through kind of the typical life cycle from data to model for an enterprise team. We'll dive into some enterprise-ready PyData APIs that we offer, talk about enterprise-grade runtime environments and how they support your workflow. And then we'll wrap up with some best practices and takeaways for leveraging PyData at scale in Snowflake. Okay, so by a show of hands, how many of you currently use Snowflake? Okay, that's pretty awesome, maybe half. If you don't know about Snowflake or you don't use Snowflake today, that's totally cool as well. The gist is basically that Snowflake is a platform that helps teams work with data at scale. So a lot of folks know it maybe as a database or a data warehouse, but it's really a lot more than that. It's a full ecosystem where you can build, run, and share data-powered applications, and that includes native support for Python, which obviously is a big focus today. But I think what makes Snowflake unique is that it's not really just a platform. There's also kind of a content network piece. So on the left, you kind of have, your Snowflake platform, compute, storage, governance, all the stuff you'd expect, plus Python workloads through Snowpark for data processing, notebooks. We have control plane APIs in Python. Basically where you write, run jobs, train models, and ship your code. And then on the right, we have kind of this content layer, which you can kind of think of as PyPI for data and applications. You can pull in third-party data sets, pre-built functions, or even full applications without managing infrastructure. And so from a Python perspective, it's really about giving you a clean and consistent environment to build with data and scale what you build without tool sprawl.
Thanks, Savannah. So as Savannah mentioned, Snowflake is a really powerful platform for data teams to work with their data. It's enterprise ready, but it's also incredibly simple. And the goal here is to really abstract away some of the complexity involved with like infrastructure, so you as a developer can focus on the insights or getting the work that you need done. And of course, you can't talk about data without talking about Python, right? So at Snowflake, we're committed to empowering Python developers to work seamlessly with their data. And that includes Snowflake notebooks. Savannah will cover this in a little bit more detail later. But notebooks makes it really easy for you to explore, analyze, and visualize your data. It also allows you to move very seamlessly between Python and SQL, all in one environment. We also have Snowpark, and Snowpark lets you use your familiar Python libraries like Pandas or the Spark API to query and transform your data directly in Snowflake while keeping everything close to where the data lives. And then finally, we have Streamlit in Snowflake. And with Streamlit, you can build and deploy interactive data apps using Python. And this is all done within Snowflake so that you can share and collaborate on your data apps in a more secure and collaborative way. And so at Snowflake, we invest heavily in thinking about open source and integrating with open standards. And our core philosophy here is to meet developers where they are, which means that being able to continue to use the tools that you know and love from the PyData ecosystem. So starting with kind of the IDE layer, right? You're not necessarily locked into the Snowflake ecosystem. While we offer Snowflake notebooks for those that want kind of an all-in-one solution, you can just as easily connect via your favorite IDEs, whether that's VS Code, Jupyter, or other sorts of IDEs. And so it's really about giving you that flexibility and working in the way to work in the ways that you're most comfortable with. And then at the second layer, there's also like API support. So we've designed Snowflake to work with familiar APIs such as Pandas and Spark so that you can query and transform your data just like you would locally. But the benefit here is that while the code that you're writing looks and feels like standard Python, the compute is actually pushed down and executed directly on Snowflake's engine, which means you get the security and the governance and the scalability benefits of Snowflake without having to change the way you work. And for packages, you can also bring in your own libraries for extensibility, whether that's your own custom package, PyPI from PyPI or Anaconda. And so by embracing open standard at Snowflake, we help you move faster. And so your team can build on existing code and skills and having to spend less time on reinventing everything and more time on delivering solutions and insights. And so in this talk, we're actually going to walk through an end-to-end scenario of how you can build a complete Python workflow in Snowflake designed for high-performance data teams. And we'll cover how Snowflake enables each step of this workflow, all the way from developing your pipeline to deploying it and to visualizations. And specifically, we'll look at how you can load data from Iceberg and then transform data at scale using Pandas on Snowflake. You can develop everything inside your Snowflake notebook and then deploy and automate your pipeline with built-in scheduling and orchestration tools. And finally, using Streamlit in Snowflake to build interactive dashboard and reporting apps. So by the end of this session, you'll see how Snowflake empowers Python developers to build, scale, and share robust data workflows all in one place. And so we're going to start with the API piece here. Many of you have probably heard of, you're at PyCon, right? So you've probably heard of like Pandas and used Pandas probably in your work. Needless to say, Pandas is probably one of the most popular data tools for like data analysis, data cleaning, and so on. And data teams love it because it's flexible and expressive, which makes it really easy for doing quick prototyping, testing, looking at your data and seeing, doing these transformations and so on. It's also like super intuitive and easy to use. And as a result, it's widely adopted. In fact, it's probably one of the most popular data science library for Python today. And so because we all love pandas, we wanted to bring that same intuitive, flexible experience to working with Snowflake data. And that's why we've developed Pandas on Snowflake. So Pandas on Snowflake is a simple unified interface that lets you work with your Snowflake data using your familiar Pandas API. And so you can easily sort of access and work with your data stored in Snowflake and even bring in data from files. It lets you build Pandas pipeline that scales seamlessly from prototype to production while being able to get the power and the scalability of Snowflake's engine. And so here's a really quick code example of how you can read data directly from Snowflake. So at the very top here, you'll see I do essentially like pd.read Snowflake and then give a reference to like my table. This could be anything from like Snowflake objects like iceberg tables, views, dynamic tables, or more. And the best part about this like pd.read Snowflake command is that it's really fast and efficient. We don't actually, when you do this, we don't actually have to load all of the data in memory. So let's say your table has like hundreds of millions of rows. Now that's going to take a really long time to like pull into memory. This read operation will typically finish in a couple seconds just because we're doing lazy evaluation here. So we don't have to pull all the data in memory. And at the bottom here, what I'm showing is an example of how you can bring in your CSV files or Parquet files. Maybe you have that lying around on like your machine, or maybe you have it in some like S3 bucket. And you might want to work with it in Snowflake. And so we support these Pandas API for I/O that you're probably all very familiar with in the Pandas API, including read CSV, read Parquet, and many others. I also wanted to call out here that on the right-hand side, you see like I have these the boxes for the QR code. Throughout this talk, whenever you see this box like this, it links to helpful resources or code examples. So feel free to take a picture and if you want to check out the code examples more. Okay, so now that I have my data loaded, it's time to transform it. And so one of the biggest challenge when we go talk to enterprise data teams when they're using Pandas is that the typical time that it takes to go from prototyping to production can take more than 6 months for Pandas. And the reason why that's the case is that, for you as a developer, Pandas just works, right? Like we rarely have to think about what goes on underneath the hood. But what Pandas is actually doing is that it's an in-memory data structure. So whatever data that you're working with needs to fit in your memory. And so what happens when you're working with enterprise scale data is that this picture starts to break down, right? Like your data might not fit in memory. And when you exceed that limit, you start to get these like out of memory issues. Sometimes you don't even get the error messages. You see your notebook kernel kind of dying and then seeing that the notebook no longer works. Those are examples of out of memory errors when the data exceeds the memory size. Pandas is also single-threaded, so things can get really slow when you start to operate on large data set. And so even if you have, like, let's say 4 cores on your machine, Pandas is not able to fully leverage that. And so whenever you're working on data that's like several million rows or gigabytes in size, this is when you start to get these errors. And so for a lot of data teams and organization, the scale challenges related to Pandas becomes really tricky to navigate. And oftentimes this comes in the form of having to rewrite my Pandas code into a more scalable framework, just to be able to tune up this knob of like, hey, I want to work with more data, and like now I have to completely rewrite my code base. And so this starts to add up in terms of the human time and development cost that's associated with building this pipeline and maintaining it. And so to address this issue, our team has spent the last 5 years developing Modin. Modin is an open source project. You can think of this as more of like a distributed, more scalable version of Pandas. It's kind of like a drop-in replacement. So all you have to do is change a single line of import and boom, you get like much much larger, you get to work on much larger data sets with better performance. And you can continue to use your familiar Pandas API, like here the read CSVs, the group bys, and so on. And the Modin runtime is much better because the operations are run in parallel. So Modin is an active open source project, and it adapts a lot of the techniques from databases and distributed computing techniques and applies that to Pandas. So earlier I talked about the Pandas on Snowflake offering that we have, and this capability is actually built on top of our open source project Modin, which enables distributed Pandas at scale directly in the Snowflake platform. And what that means for developers is that you can continue to run your existing Pandas code right inside Snowflake. So imagine on the architecture diagram here, like imagine you're a user, you're writing some Pandas operation like pd.concat to combine two data frames. Behind the scene, what this is doing is that this operation gets transpiled or translated to SQL, and it's pushed down to run on the Snowflake engine itself. So it provides this familiar Pandas experience, but with the scalability and performance of Snowflake. So with Pandas on Snowflake, you can actually run Pandas on a terabyte of data, which is something that would be really hard to fathom even with running vanilla Pandas in memory. Our benchmark with representative workloads has shown that Pandas on Snowflake scaled to like a terabyte of data running on one of these workloads in less than a minute. And in cases where like traditional Pandas would have run out of memory. On even smaller workloads, like if you look at the bar, the second bar to the left here at 10 gigabyte, we observe up to 30x faster performance. And so this really unlocks the full power of Snowflake for Python developers, allowing them to use this intuitive Pandas syntax that they know and love, while benefiting from this enterprise-grade performance scale and governance. We've been continuing to improve Modin and our Pandas on Snowflake experience. And so one of the things that we hear a lot from our customers and folks in the community is that Pandas is like only one of many amazing kind of PyData tool that's out there. It's not really used in isolation, right? So it's often combined with other third-party libraries for data visualizations, machine learning, statistical analysis, and so on. And so this is why one of our recent updates focused on interoperability with the broader PyData ecosystem. So we've recently added support for the data frame interchange protocol, which is made possible through the Modin open source project, which means that now you can use Pandas on Snowflake with the broader libraries in the PyData ecosystem that also implement the data frame interchange protocol. So that includes libraries like Plotly, scikit-learn, Altair, NumPy, and many more. So if you're interested in any of sort of what I talked about earlier and trying out Pandas on Snowflake on your own, it's easy to get started. You could just do like pip install. I have the commands here. And then also take a look at kind of the 2 QR codes that links you to the quick start and our documentation for more examples on how you can get started. Cool. So I'll be handing over to Savannah, who will talk about notebooks.
Cool. So we're going to switch gears and talk about runtimes and environments. So we've talked a lot about data access, transformation, particularly with Pandas on Snowflake, but now we're going to talk about kind of taking that data that Doris has been working on and moving it from kind of this data exploration phase into like creating a model with Snowflake on notebooks using our container runtime. And I'm not going to spend a ton of time explaining what a notebook is because we're at PyCon and I'm assuming a lot of you probably already know, but if you're familiar with like an IPyMB file, notebooks should make you feel right at home. It's got that same interactive context that you're familiar with, plus I think some like really great features that make it a really good surface for writing Python. And even though this like session is based on, or like kind of focused more on complex enterprise grade scenarios, I'm going to start with like a brief intro because I think everyone kind of starts by getting familiarized with the tools that they're working with and the data that they're working with. So spinning up a notebook in Snowflake is super straightforward. You create one, you hit start, boom, you're running. And we built this so that you can get running with your data right away inside Snowflake, not bouncing between different tools. But I think what's really neat here is that you create your notebook and then establish a connection to your data with like 2 lines of Snowpark code, and then you're kind of off to the races. So you're not messing with like configuration, you're not moving data around, you're not dealing with infrastructure. It all just kind of works. And you can use Snowflake notebooks with data from other sources as well. So if you have data that's stored in another cloud service provider or in a local CSV, totally game. I'm not going to spend too much time covering like every feature that we have, but there are a couple that I did want to cover because I think they're really nice for productivity. And so while I'm obviously all in on Python and we're at PyCon, I do think that it's like pretty powerful to be able to like blend SQL and Python in notebooks. Because I think sometimes it's just like the quickest tool for the job that you're trying to accomplish. Like sometimes writing a straightforward SQL query is quicker than just to pull data and look at the table and kind of get like a glance of what you're working with. And then, switch into Python for more complex analysis, transformations, or machine learning. But I think what's really cool about Snowflake notebooks is that you can reference variables and results between SQL and Python cells. So you kind of have this total interoperability that eliminates the necessity of like switching between tools or copying data. It keeps everything in one place and really streamlines your workflow. We've also been talking a lot about accessing and transforming data, but what happens here when you like really want to explore your data? Like maybe you have some like, basic statistics that you printed out, but like to me, when you really want to explore data, that's where like Streamlit really shines. And I think that if you're at PyCon or you're a Python developer and you haven't tried Streamlit yet, you're totally missing out. The first time that I used Streamlit, which is an open source project as well, like it completely blew my mind. Having spent a ton of time building dashboards and charts with other packages, I was just like truly so impressed with how powerful it was. And so if you're working with like a new data set, maybe you're in your Snowflake notebook, or even maybe you're in VS Code, you want to run some like exploratory queries, and you have some data frames, you maybe want to go like a little bit deeper. You want to see patterns and trends and outliers. And instead of looking at those static tables or charts, Streamlit allows you to go from into an interactive dashboard in minutes. So like this GIF is literally less than 100 lines of code. I went from like raw data to like a dynamic interactive visualization literally in just 100 lines. You can add sliders to filter your data, buttons to toggle views, charts that update in real time as you manipulate controls. And for data exploration, I think this is totally invaluable. And if you need to like share your findings with others, Streamlit makes it incredibly compelling or it makes it really easy to create these like compelling and interactive charts, reports, which I'm going to talk about a bit later. Okay, so we've been exploring our data, we've gotten familiarized with our data, and maybe, it's time to start building that model that we've been alluding to. But before we dive into Snowflake ML, I want to talk about some common hurdles that we see Python developers and enterprise experience when they move from, building a machine learning model to deploying them in real world settings. So first, there's kind of this classic trade-off between cost and performance. We all want our models to be as like accurate as possible, but that comes with like a higher price tag, especially when we have, we're using more complex algorithms or have like larger data sets. And so finding that sweet spot where you get good results without breaking the bank is a challenge that many of us face. And then there's the issue of scalability. So like as our models become more intricate and our data grows, like we need infrastructure that can really handle the load. And dealing with these massive data sets, complex features, large models often requires sophisticated systems that to manage and execute everything efficiently, but that can also turn into like a pretty large technical hurdle. And in production environments, like reproducibility here is like really key. We need to be able to like recreate our environment or our model and our environments really consistently and ensure that our build environments are consistent and isolated. But that is often like a DevOps task that's like either outside of the comfort zone that you might have as a data scientist, or frankly, like maybe just not what you want to be spending your time doing. And then finally, like we can't really forget about compute. So like, especially with GPUs, like many machine learning tasks, particularly those involving like deep learning or LLM development, require GPUs. And so getting access to these resources and integrating them into your workflow can be like a real headache. And again, like if you don't have that extensive infrastructure knowledge or DevOps experience, it's just like peripheral to the job that you want to be done. You're spending time doing things you don't really want to do. And so these are kind of some of the common challenges that we see developers run into when they move from development into production. It's not just about building the model, but it's also about making sure that it's reliable, scalable, and cost-effective in a real-world setting. Okay, so let's talk about how Snowflake's trying to make machine learning easier and addressing some of these pain points. And so we've built a comprehensive set of capabilities that we call Snowflake ML, designed for helping with that end-to-end machine learning workflow within Snowflake. And you can think of it kind of in 3 layers. So first we have the ML development layer, and this is where you're going to spend most of your time like building and experimenting. And in this talk, we're going to be focusing on Snowflake notebooks as the primary interface for developing your machine learning workflow. But you can use whatever editor IDE that you want. Like if you're using Jupyter, Hex, or VS Code, or you want to do like headless ML jobs, like that's also totally fair game. Then we also have our ML APIs, which are kind of powerful extensions that speed up your training, especially when you're working with like popular open source frameworks. They help you scale your training and make your models more accurate and efficient. And then underpinning all of this is our container runtime, which is really the foundation that provides pre-installed images with all of your favorite PyData packages, as well as access to GPUs, CPUs, all that good stuff. And it's what makes the whole system really performant and scalable. And these layers, they're not like isolated. They're kind of designed to work together seamlessly. Like you can develop in a notebook and leverage the ML APIs for faster training and then rely on the container runtime for the heavy lifting. But it's also not just like about development. You'll see here that we also have features for ML ops, so model registry, serving, deployment, as well as observability tools. So whether you're experimenting with open source libraries or building like a more complex production grade workflow, like Snowflake ML really has you covered with kind of an integrated toolchain. So talking a little bit more about like the heart of what makes machine learning so powerful in Snowflake is the container runtime. This is a fully managed container-based environment built to like meet the demands of large-scale machine learning workflows. So under the hood, everything is built on Snowpark container services and uses Ray for distributed computing, which means you get like a highly parallelized environment for both data ingestion and model training, and it scales automatically based on what your workload needs. The runtime comes with the latest machine learning packages, so like PyTorch, TensorFlow, XGBoost, LightGBM, scikit-learn, all pre-installed and CUDA ready if you're using GPUs. And there's also, if there isn't a package that you need, you can just pip install it. We've also optimized the training APIs to scale out, so when you're handling large models, the container runtime uses a distributed orchestration paradigm to handle it and securely and without you needing to really think about the plumbing. And so this is kind of how Snowflake is bringing the tools that you love into like a more frictionless, scalable, and governed environment. Okay, so maybe at this point you're thinking like, this sounds really great, Savannah. Like, how do I actually get to use the container runtime with Snowflake notebooks? And thankfully, it's actually like super straightforward. You can either like start from scratch or upload your own notebook file, select run on container, choose either between GPU or CPU, and that's it. There's no cluster provisioning, there's no YAML, there's no setup headaches. Like you just get to writing code. And behind the scenes, we're like spinning up, the dedicated service on Snowpark Container Services, which is our managed container platform, and then the runtime's like preloaded and all that GPU, all your accelerated compute is configured for you. It also scales like up and down depending on what your workflow needs. But the real power here comes with like how we handle data specifically for machine learning. And so as I mentioned before, the container runtime is like designed to be easy, secure, performant with Snowflake ML APIs. The container runtime simplifies the work for you as an end user by provisioning isolated compute resources with secure and managed node-to-node communication. So with our data connector API, the container runtime is able to leverage all of your available compute resources to read and load data in parallel, thanks to leveraging Ray data under the hood, which means that we can take advantage of their multiprocessing, shared object store, and strap on additional optimizations to even out batch sizes and batch data and memory for optimal performance. And this distributed processing power helps eliminate a key pain point we often hear from customers, where a significant portion of the processing time in large-scale training or batch training process is spent actually just loading the data. And this API is used by default by all the Snowflake trainers, so you can leverage it directly to transform your data into third-party data objects, such as a Pandas data frame. And so, for example, in one of our benchmarks, the container runtime loaded 81 gigabytes of data into a Pandas data frame in just like 50 seconds. And an equivalent open source setup, not leveraging all of your compute resources efficiently, took nearly 9.5 minutes. And so when you use Snowflake distributed trainers, you are bringing your own custom training code, and Snowflake manages kind of the scheduling distribution across resources as you define it. Under the hood, we're, again, using that Ray framework to facilitate distribution of work across the devices in the cluster. And Snowflake currently supports 3 distributed trainers, PyTorch, XGBoost, and LightGBM. And to give you an idea of like the performance improvement, we can consider this benchmark. So to compare performance for the XGBoost estimator, we generated a training set with various sizes, range from 7 to 15 features double type, and train a basic XGBoost regression model using the official recommended API. And we found that running the exact same workload on distributed Snowflake ML APIs was about 3 to 7 times faster than running open source XGBoost. Cool. And so we, again, like provide kind of the access to GPU and accelerated compute without any configuration. Your admins basically just get to configure the compute pool so that you're exposed to the right settings when you go and you create your notebook. And again, you're just choosing between like CPU and GPU, and then you're kind of good to go. And you can kind of take full advantage of all of the acceleration without driver setup or compatibility wrangling. And we orchestrate multi-GPU usage behind the scenes as well when you use the distributed training APIs. So if you want to like run large workloads without wrestling infrastructure while staying in the security and governance model that Snowflake offers, this is really the way to do it. And then finally, I'm not going to like read through the package spec, but I just wanted to call out again that like the container runtime comes with like 50 of your favorite PyData packages. Basically all the like most modern stable versions of the packages, and you're welcome to install whatever else you'd like on top of that using pip. Okay, so we've gone through the process of maybe like developing and training our model within the notebook, which is cool, but like in the real world, your data is changing all the time. And if our data changes, we want our model to be like up to date and reflect those changes. We need to keep it fresh. And so with Snowflake notebooks, you can also like easily automate the execution of your notebook on a regular schedule and like set up effectively a cron job for it. And so as you can see in this GIF, you can set up like a nightly, weekly, or even more frequent schedule if you need it, meaning that your model is automatically retraining on the latest data without any work from you. And this way, when we pull our model into our Streamlit app or another BI tool, we can be pretty confident that it's working. It's using the most current and accurate insights. So like no more worrying about stale data, outdated models. Scheduling keeps everything really fresh. Cool. So maybe we built the model, we scheduled it, everything's working super well, data's up to date. We want to share it with our stakeholders. So like, how do we do that? And it's actually really easy to be able to do this when we use Streamlit for reporting. So again, Streamlit's an open source library, but we also offer like a hosted version of Streamlit that we call Streamlit in Snowflake. And so you can grab the model directly from Snowflake and use it within Streamlit. And to me, this is actually really powerful because these aren't just static charts. We can create these rich interactive visualizations where the user experience actually updates the model in real time. So imagine a dashboard where someone can adjust a slider and instantly change the model predictions. And those are reflected in the visualizations. And of course, like the governance portion of this is that we can actually control who can access and like run this dashboard. So you can share with stakeholders with the right permissions and make sure that everyone has the right access and while keeping everything super secure. Cool. So if you're interested in learning more about Snowflake notebooks for ML, or you want to try the quick start, you can grab these QR codes. Again, we'll put up the QR code for the slide deck at the end of this as well, so you can store it for later. Cool. So we've covered a lot of ground from accessing and transforming data to build and train machine learning models. Now we're kind of bringing it all together to talk about the complete journey from data to insights. So first we started with loading our data. We saw how easy it was to load the data from an open standard format, maybe like Iceberg, leverage the power and familiarity of Pandas, but with that like really high performance enterprise grade compute power. You can bring your data into Snowflake without complex configurations, moving it around, transformed it, and whether you're working with like gigabytes or terabytes of data, you can do this efficiently without running into any of those like pesky out of memory errors. And then we moved into our development phase where we saw that like Snowflake Notebooks provides this all-in-one development environment. And this is where we explored and experimented. We built our model all within a Python-friendly interface. And once our model was ready, we can like deploy it to our model registry, refresh the notebook on a schedule to make sure our model's fresh and up to date as our data evolves. And then finally, we kind of talked a little bit about BI and reporting, where we took our model, turned it into actionable insights using Streamlit and Snowflake.
Awesome. So just to recap, in our talk today, we shared some of the key lessons and learnings about what it takes to support enterprise-ready Python for high-performance data teams in Snowflake. And at Snowflake, we're deeply committed to integrating with the PyData ecosystem. And today you saw how we're delivering this in the Snowflake platform. Our product philosophy is really simple. Like we want to keep everything about our product experience easy, open, and trusted. And we want to make these powerful tools accessible, interoperable, and reliable for enterprise teams and developers using the PyData tools that you know and love. And so thank you again for joining us for the talk today. And before we wrap up, I have a couple quick call outs. So if you're looking for hands-on examples of any of the things that we covered today, or more examples of how you can leverage Python in Snowflake, go check out our GitHub Snowflake Python recipes, which is a collection of code snippets, patterns, best practices on how you can do Python in Snowflake. The other thing I wanted to also call out is that we'd love to hear from you. As part of PyCon, we are running this short 5-minute survey to learn more about your experience as a Python developer, and your feedback will be really helpful to help us shape better tools and experience for the community. And so please take the time if you can fill that out. And remember to stop by our booth. Our booth is booth 309, and our Savannah and I will both be at the booth tonight during the opening reception. We'll also have many other Snowflake experts at the booth throughout the conference. So come say hello, ask us anything, and of course, pick up some swag. So thanks again for joining us for the talk today. With that, we are happy to take any questions. You want to take questions here?
We can take questions here.
Yeah, we can take
also
questions.
Just like loiter.
Yeah.
Whatever works.
How does Snowflake handle data compliance, such as SOX or HIPAA compliance?
Do you want to? Oh, good. I think this is part of like the overall Snowflake platform. Like we do have like security like groups and things like that enforces that. I think the other thing that the Snowflake platform provides is like the all-in-one governance. So your admins and your developers, your admins can configure what your developers can or cannot access. So that's another aspect where like you have that ability to kind of have governance on your data.
Okay, so like different governance groups. What about like auditing?
I am not an expert on that, to be honest.
Sorry, thank you.
Yeah.
What would it take to go from 0 to hero for the average user? Somebody who's never been in Snowflake, you know kind of what I'm going through. How long would it take to go from 0 to hero on that?
I mean, ideally, the flow that we showed today, you open up a Snowflake notebook and Snowsite, all of that is UI based. You pick a couple package that you like using and then start coding in Python and SQL. So that's really like the starter experience. And then I think where we're coming from is we always want to provide that like really easy to get started experience. But then if the analyst wants to do more, they can like bring in their best in class models. They could add more packages. They could deploy it and so on. So I think that is really like the starter experience is like open up a notebook and start hacking on it.
Do you have example data as well in those examples? So
Yeah.
you can just start playing and start figuring things out?
Definitely, yeah. You could either use some of our example data, or if you have data in S3, it's like a single line of code to set up like kind of, essentially being, I think I had an example of that, like pd.read Parquet or read CSV or something from the S3 bucket, and then be able to start working with that right away.
Yeah, and the quick start on the right here like walks you through like the kind of whole process. Like you can bring in like and in the GitHub repo that Doris and I linked, there are like sample CSVs and stuff that you can play around with as well.
So the original question was, what's the timeline on that? Is it a couple weeks? If you're doing 8 hours a day, let's say 8 hours a day, is it a couple weeks to get up to the hero level?
I think it really depends on like what your workflow looks like, right? Like if you're going from don't have anything in Snowflake to I want to do like data engineering, machine learning, data science, BI report, like that's a lot of steps. But I think you can kind of like piecemeal it out. Like it kind of depends on what your priorities are and what workloads you're trying to migrate first.
Thank you very much.
Oh, I can run it.
Oh.
Thank you. Hey, I'm kind of new to Pandas data frame, and also they are Snowflake. But I wonder, as you mentioned, Pandas is basically a top-level library, which is a single-threaded, and Snowflake is more like some kind of distributed data store. How did you guys build the middle layer, which basically scale up the computation on Pandas?
That's a really good question. And I mentioned the open source project Modin, which essentially allows this, the top layer, like being able to support the Pandas API. But essentially, we have an internal algebra, so sort of like an IR layer in Modin that compiles that like API layer down to whatever like execution backend. So it could either be like running on Snowflake, but we also actually support like open source backends like Array and Dask. And so that like Modin is kind of the secret sauce that allows us to go from like the Pandas API essentially down to whatever instruction that is necessary to run the compute at scale.
Sounds good. Thank you.
Hi, thank you. My team of analysts, I'm the engineer for a small team of analysts. They're all based on R workflow, R Markdown, even publishing to Tableau dashboards. If I'm trying to articulate this kind of plan for them, as far as going to a cloud-based, we use a SQL server, but if we go to a cloud-based like Snowflake solution, am I talking about trying to retrain them onto a Pandas-based notebook workflow, or are there easy crossovers or integrations with R-based like workflow that we have now? Basically, am I talking retraining or recalibrating?
So just to clarify, you're saying that you have local notebooks now, or like notebooks somewhere else?
We Markdown document our Markdown, so pretty much our version of notebooks.
Okay.
But that's not translatable to Python, as far as I know.
Yeah.
That would probably be reconstituted, but I'm wondering if those can be hosted within Snowflake in any way. Not nearly as well as this, but or I'm better off trying to push them towards learning to write these from scratch in Python.
Yeah, I mean, so Snowflake actually started out more as like a SQL platform, right? Like I think like traditionally, like more traditional data warehouse database. So we do offer like the Snowpark container service is like truly just a container that you can run whatever you want in. And we have infrastructure built on top of that. But it sounds like that could be potentially a good fit for you and kind of workloads that you're talking about. So you don't necessarily like have to use the notebooks interface if that's not what suits you.
Thank you.
I think there was another question. Oh, okay.
Hope somebody dropped the phone. I'm trying to scale up a Streamlit app, and I found some of the default tutorials a little weird to work with. Do you think I should skip right to doing the Snowpark and containerizing it and putting it on there?
So like
I'm not going to be able to dive into like the bugs and right here.
This is like a multi-page Streamlit app or something. I know that we do have like some opportunities to have what I would call maybe more advanced quick starts or more advanced like samples. We do have some folks that are like resident experts in Streamlit, so maybe catching them at the booth later might be like a really good opportunity to walk them through like exactly what you're looking at.
Yeah.
But yeah, I don't necessarily think you have to go to containers. I think it'd be interesting to kind of hear.
I'll come find them.
Awesome. Oh, behind you.
Yeah, I just wanted clarity on Modin. Is it just for internal use for Snowflake? And if it is also for external, why wouldn't we just use Modin instead of going straight to Pandas?
Yeah, so Modin is an open source project, so anyone can use Modin. All you have to do is like pip install Modin, and you can start using it. The difference between like the Modin and like what I talked about Pandas on Snowflake is that ability to like push the compute down to the Snowflake layer. So it works. So the Pandas on Snowflaking works within our like Snowpark Python kind of ecosystem. And so you need both Snowpark Python and Modin to be installed for that Snowflake push down capability. But otherwise, like anyone can use like Modin today and with like Ray and Dask as a backend, and that will also give you the parallelism. It just won't be translating to SQL and pushing it down to Snowflake. You would need a Snowflake engine or Snowflake backend for that.
Thanks for the talk. It's very interesting. So I'm just curious if you could explain more about what the Snowpark ecosystem is and explain Snowpark just as someone that's not familiar with Snowflake.
Yeah, definitely. So as Savannah mentioned, like Snowflake started as more of a SQL first. Like most of our customers were using SQL to interact with Snowflake. And over time, like we saw that, people wanted to bring their own tools. They have Java, Scala, Python, and like all these other languages that they were using. And so Snowpark was really like a way of wanting to support those additional languages, but still kind of being able to leverage the security and the governance and the scalability of Snowflake. And so the way that Snowpark kind of the libraries work is that you would write, let's say in Python, and then it would compile that code down to something like SQL and then run on the Snowflake engine. And then I think the other part of this, which is enabling kind of flexibility for developers, is what Savannah briefly mentioned, which is the Snowpark container services. So container services are sort of, think of them as like Docker images, and you can run full-blown web applications or like, whatever you're used to running in containers, you could do that with container services. So that takes sort of the flexibility to the next level in being able to do full-blown applications.
Into it.
So I guess the gist of it is that it's compiles down to SQL for any language that's supported, basically, in Snowpark, like essentially a translator.
Yeah, and I think
More or
like
less.
the other component here is that Snowpark is really focused sort of on like the data transformation layer. So like if you're doing data operations, like Pandas is obviously one example. We have other APIs that are like more targeted at the like I'm cleaning, transforming my data. We also have like control plane API. So maybe you want to like manage your resources using Python. You want to create a database. You want to create tasks and jobs. That's all also programmatic through Python, but not part of this like the Snowpark like bucket, I guess I would say.
Hey, following up on Snowpark, I wanted to know like if I have a piece of code which is running on CPU, and if I wanted to move to a GPU to make it faster, what level of optimizations would I need to do as a developer, and what level of optimizations would Snowflake take care of?
Yeah, so like Snowflake with the container runtime, I think like the special sauce is like you don't have to focus on like integrating the hardware, right? Like you're not focusing on like, oh, I need to figure out what drivers I need to do and like have CUDA compatible libraries. Like we provide that all out of box for you. You still might want to like, leverage like multiprocessing or threads or something in your own code. But like the idea is that you're not managing the infrastructural pieces of that. And then like obviously also with the ML APIs, you're getting the like drop-in replacements for us to like run distributed, like the workload distributed across your whatever hardware that's provisioned.
Thank you.
Oh.
Is compatibility with SQL Alchemy plug and play?
Yeah, I mean it's included in like the packages that you can install. I think like I don't know that it's bundled in the container runtime, but you can install it whatever you'd like. inside of your notebook or whatever other environment you're using.
Thank you.
Any other questions? Oh.
Thank you. So I usually like using the Snowflake extension in VS Code. Is there any potential to essentially have the same capabilities as the Snowflake notebooks in VS Code? So where you would be able to use VS Code, but get that same like Pandas on top of Modin sort of capability?
Yeah. So everything that we talked about today on like the loading and the transformation piece, and you can actually run with. It's essentially like a client-side library. So you really you can just do like pip install snowpark, like snowflake-snowpark/-python, and then install that in your local environment and run with like VS Code. So all of that. Like the Modin stuff can work with that. That being said, we are also developing like new capabilities within Snowsight to give you more of a multi-file experience within your workspace. So a lot of those new things are coming soon to hopefully give more of a VS Code feel within Snowsight, so that you get the flexibility of choosing any of those environments.
Yeah, but I guess like just to double down, like use the environment that you want to use. The APIs will work anywhere. So I talked about notebooks. I work on notebooks, but I also do write code in VS Code in my free time. So, oh, okay, we gotta run that all. I can speak up. I just want to make sure it's captured on the recording. If there's.
It's a very good question. How does it compare to Databricks? What differentiates this from Databricks?
So I think that, are you talking about the notebooks or in terms of the APIs?
All the solutions that you provided in terms of end-to-end, like from the inception to BI reporting. Of course, Databricks, I don't believe, provides that today. It's more notebooks and scheduling that you refer to, and Python and SQL in the same notebook. It enables all of that. So I'm just curious how it differentiates from that and what Snowflake provides that Databricks doesn't.
Yeah, so actually a lot of our customers do use like both of these software. A lot of customers nowadays are on multi-cloud. And so obviously these comparisons make sense. I would say that a lot of what we talked about today, like if your data is in Snowflake, these solutions are like best designed for those use cases. If your data is obviously like somewhere else, then there's different like advantages and things like that. But one of the things is that if your data is in Snowflake and you're operating it in other environments like a Databricks notebook or like a SageMaker notebook, you're actually getting sort of charged kind of the I/O of moving data back and forth between Snowflake and those environments. So from that aspect, having that all-in-one solution like we talked about today, and being able to use your familiar PyData libraries, that is a huge advantage in just being able to consolidate everything and doing things the most efficient way, given that your data is in a secured, governed environment in Snowflake. Yeah.
I mean, obviously it's kind of hard to do a feature by feature comparison across, right? Like, but I think one of the things that I'm most excited about the work that we're doing at Snowflake is really trying to be in this governed environment where you have like, your notebook is a database object. It lives alongside your data, right? And like, to me, that's like less friction. It's also like better governance. But like one of the things I'm most excited about is how we're doing that, but still embracing the open standards and open formats that like the ecosystem is moving towards, like our work with Iceberg, and also like trying to really do right by Python developers by giving them the tools that they need within this like very, governed, highly managed environment. Yeah. Going once, going twice. We'll be around as well, so you can catch us at the Snowflake booth too.